Hey, good morning everyone. It is Monday, April 13th, and I am so glad you're watching this video. I miss you all and I hope you're staying safe. Before we start, some quick announcements. My quarter 3 grades are closed. Everything that you did last week is for quarter 4, and everything that's this week is also for quarter 4. I'm still taking work from last week since it was from quarter 4. Even though things are due on Saturdays, if you need an extension, just let me know. Especially for those of you if you weren't able to get in the classroom right on Monday. All right? So just because you weren't able to finish it doesn't mean you can't still do the work from last week. All right. So our objective for today is students will be able to calculate the value of logarithms using the definition. Now, you may remember the definition of logarithms. If you do, go ahead and skip forward in the video and just take a look at the examples or take a look at the notes that I'm going to post with this video, because this is a lesson that we've done before. If you need a refresher, stick around. Our agenda today is, in the video we'll have a do now, go over the definition, and do some examples. Your classwork will be practice problems, and I will go over some directions for those at the end of the video. So take a second for the do now, pause the video, and see if you can complete these, well, it's 4 different things on your own. Okay, so hopefully you had a chance to try these on your own. When I say, what power of 6 is equal to 36? I'm really thinking, okay, 6 to some exponent will equal 36. So 6 to what power is 36? That's got to be 2. 6 squared is 36. So my answer here is 2. What power of 2 is equal to 32? Same thing. 2 to the what equals 32. Now, if you're using your phone for a calculator at home, let me make sure y'all know how to do this on the calculator. So when you have your regular calculator open like this, you want to flip it and look at this x to the y button. So if I put in 2, then I'm going to hit x to the y, and then whatever number I'm trying. So say I want to do 2 to the 4th power, then equals 2 to the 4th power is 16. So that's not what we want. We want 2 to maybe something bigger. Let's try the 5th power. That's going to be 32. So I got 2 to the 5th power is 32. So if you're using your phone calculator at home, that's how you do that. All right, very similar thing for number 3, solve for x. 5 to the x equals 25. So I'm asking myself the same question, 5 to what power equals 25? We should be getting that x equals 2, because 5 squared equals 25. And we just saw in my calculator that 2 to the 4th power is equal to 16. So in this case, x equals 4. And my answer here was 5. All right, moving on to our definition. The definition of a logarithm is if 3 numbers, L, b, and x, with b greater than 1 or 0 is less than b is less than 1, are related by b to the L equals x, then L is the logarithm base b of x, and we write log base b of x equals L. So if you need to, pause the video, take a minute to write that definition down. The most important part I want to note here is that we'll be using log base b of x equals L because of our exponential statement, b to the L equals x. So we're really going to be trying to figure out what is that L value here. And we're using b is always going to be the base of our logarithm and the base in our exponential equation. So for example, the directions here are compute the value of each logarithm, verify your answers using an exponential statement. Okay, so I want to figure out, what does log base 2 of 32 equal? And what I really want to do is write this as an exponential statement. So if we say this equals L, based on our definition, I'm going to have some this is my logarithmic statement. I'm going to have some exponential statement, b to the L equals x. In this case, my b is 2. The base is 2. And my x value, what's in the x spot from my definition, is 32. So really I'll have 2 to the L equals 32. And 2 to what power equals 32? From our do now, we know that this L has to be 5, because 2 to the 5th equals 32. So we say log base 2 of 32 equals 5 because 2 to the 5th equals 32. I call this my because statement. That's my exponential equation. Let's do one more. If I have log base 9 of 81, I want to know what that's equal to. So I'm going to think, okay, 9 to what power equals 81? 9 to what power equals 81? We should be thinking 9 times 9 is 81, right? So that's how many 9s? That's 2 9s. So I'm going to say 9 squared equals 81. So my answer to complete the logarithmic statement is 2. My exponential justification is because 9 squared equals 81. For number 3, we have 13 and 13. That's kind of different, right? So I want to think, okay, 13 to what power gives me 13? So I'll start my because statement, because 13 to what power equals 13? I know 13 equals 13, so I really only need 1 13. 1 13, so I've got a power of 1. 13 to the first power equals 13. So my answer here is 1. One more weird example. 13 to what power equals 1? 13 to what power equals 1? If you remember properties of exponents, this is going to be our 0 property. So we know if we have anything to the 0th power, that exponential expression will be equal to 1. So in this case, my logarithm value is 1. All right, so these are the kinds of statements that I'm going to be asking you to complete in your classwork. I want you to give me the value of the logarithm and a statement that justifies the value in exponential form, right? So you'll have both a logarithm statement and an exponential statement. All right, one more example. This example says, complete the following table of values using the given logarithmic function. So my logarithmic function is f of x equals log base 2 of x. So in my table, I have a list of x values, and the directions say to complete the table using the function. So my f of x is my function log base 2 of x. So what's really happening here is I'm going to substitute my x value into this function for every single x value. So I'm going to write that f of x for my first x value will really be log base 2 of 1. Now I need to compute that. So I want to know 2 to what power equals 1. From my earlier example, we know that if we have a 1 here, then we need an exponent. 2 to what power? 2 to the 0th power equals 1. And we'll write that because statement, because 2 to the 0th power equals 1. I'm going to draw a line between those two columns because really what I want to know is that 0 value. And we can say this is the verification or the justification. All right, now we'll substitute 2 into this function. So I'll have log base 2 of 2. And I want to know 2 to what power equals 2? That's going to be 1. So because 2 to the 1 equals 2. How about 4? If I've got 4, I want to substitute that in to the x for the x value. So I'll say log base 2 of 4 equals, and I want to know 2 to what power equals 4? 2 squared equals 4. And we keep going. Log base 2 of 8. 2 to what power is 8? That's going to be 3, because 2 to the 3rd power equals 8. That would be 2 times 2 times 2 equals 8. And log base 2 of 16 will equal 4, because 2 to the 4th power equals 16, right? 2 times 2 times 2 times 2 equals 16. That's 4 2's. Now, once I've got these f of x values, we've done this before. We've graphed these. So really, I have 5 points here. My first point, my x value is 1, and f of x, which also would be y on a graph, is 0. So that's going to be the point 1, 0. So I'm going to go ahead and graph these. So if I go over 1 and up 0, I'm right here. And that's going to be my point 1, 0. Next, I'm going to graph the point 2, 1. So I'm going to go over 2, up 1. That's the point 2, 1. Then I've got the point over 4, up 2. I'm going over 4, up 2, and that's my point 4, 2. 8, 3. We're going to go over 8, up 3. That's my point 8, 3. And finally, my point 16, 4. I'm going to go over 16 and up 4. And that's my point 16, 4. So what we've done here is taken our table of values on which we calculated the values using the definition of the function, and I've graphed them. So I can connect these points, and this should look familiar. This should look like our graph of a logarithmic function. So you'll have one example of graphing a logarithmic function, and we will talk more about that in the future. Okay, so let's go over the classwork directions real quick. Classwork directions. There's 2 options you have, and I'm going to be honest with you, I am much more familiar with option 1. So option 1 is you can complete the classwork on a piece of paper with a pen or a pencil. So that would look like me taking a piece of paper, write your name on it. So take a piece of paper, you write your name on it, write classwork 5 on it, and then you complete all the problems, right? Then you can take a picture and upload it to this assignment in Google Classroom, okay? So there's a place in each assignment where you can attach a file, and then you should be able to choose a photo from your phone to attach to the Google Classroom, all right? And then you hit turn in. Option 2, this option's a little trickier for me because I don't actually know how to do it, to be completely honest. I'm not able to see the student view of Google Classroom, which makes things really difficult. But I've posted a video that goes through the example of how to download the PDF and use the document editor that you can get on your phone or a computer. And so it seems like you would download a copy, use that add-on that is in the video I posted in the stream, or if you've got another way, I know some of you have been successful already, so that's been great. So you're editing directly onto that document and then saving your document, attaching it, and still turning in through the Google Classroom assignment. So both ways, you've got to attach either a photo or a PDF or a Google Doc, right, to show me your work. If you've got questions, if you're having trouble, feel free to contact me. If worst comes to worst, you can always send me your work at my phone number, which is here and on the classroom. All right. Good luck. Please remember, I've got my office hours 11 to 12 every day, or 6 to 6:30 in the evening on Monday and Wednesday. All right. See you all later. Be safe. Have a good day. Bye.